Hey folks, Mac T. What's all the fuss about? Plastic oil pans? Holy cow, have you guys known that plastic oil pans have basically initiated back in the 90s with Daimler in Germany? That's how long they've been around. And guess what? Some of the major players in it are Alensys AG, BASF is a major player. BASF SE, DuPont Automotive, and Magna Exteriors. All big players in the game when they started designing what they call thermoplastic oil pans. Now, I'm not so sure why everybody's upset about a plastic oil pan. You got plastic valve covers, you got plastic intakes, and all of them have essentially a thermoplastic with fibers in it. Okay, so these fibers, of course, add rigidity and strength to the plastic, so when they injection mold them or blow form them or whatever the case may be, then these also have inherent consistencies of strength. Now, you will find out over the time, true actual history of everything, that some of the other ones that started doing this was Dodge. Early 2000s, Dodge started doing it with their Hemis. Then Ford jumped onto the boat, started doing it with the F-150s, the Mustangs. Everybody's going to plastic, thermoplastic oil pans. Now, there's a big reason behind this. One, EPA wants better gas mileage. How do you get better gas mileage? You reduce weight. By reducing weight, you get better gas mileage. It might only be a slight sliver, but if you add all that up together, you end up with better gas mileage for every cost savings that they get for weight, because it takes energy to move something. Therefore, the companies want to reduce weight. Also, the true fact is economics. How much does it cost to make a plastic oil pan versus casting an aluminum one? You got it. If they make the plastic one, they save money. So they get better gas mileage, they save money in the manufacturing process of it, and then they take and they also get another benefit out of it. They get strength. That's right. They've tested aluminum, cast aluminum oil pans against the plastic ones. And the plastics ones were just poured in a form and say, here you go. There was some engineering that went into it. And if you look at the oil pans in the picture up here, you'll see that they have what they call the honeycomb. Okay? The waffle grid, as they say. This waffle grid that they design into these oil pans has two functions. That's right. One is structural. They have the main base plate of the oil pan, but then they build all these waffles around it to give it more structural stability. That structural stability also comes into effect in their testing. They have proven through testing about 50 or 60 miles per hour in rock strikes on oil pans that the plastic oil pan survives and does not break. The aluminum oil pan breaks. So the plastic oil pan is actually stronger for smacks than the aluminum one is. Now, how did they achieve this? Well, the waffle design is not only structural, but it's sacrificial. These strikes that they hit, the waffle ridges absorb the impact and keep the pan from breaking. So, hey, engineers were smart in this aspect. They designed a pan that's not only rigid and strong, but also protects the pan using that waffle ridge design. It sacrifices the waffle ridges in order to make it stronger. But there's more to it. Yes, there is more to it. These plastic oil pans in their manufacturing also have to survive another test. That's right, folks. They take the whole engine block, they raise it up off the ground, and they drop it. Plastic oil pans surpassed aluminum oil pans in that test too. They did their job. They're absorbing the weight, they're adding structural integrity, reducing weight, and reducing cost. all while taking and still being usable. Now, one thing that plastic oil pans don't have over cast aluminum is if you want to take and melt aluminum, you got to get a real high temperature. I think I remember it's 16 or 1800 degrees in order to melt aluminum. Plastic injection molding, from what I know in injection molding aspects, you start getting up to about 600 degrees, everything turns to jelly. Okay, it's all squishy. So, but how many of your engines get to 500 or 600 degrees? None of them. If they're at 500, 600 degrees, guess what? They're on fire. That's right. It's done anyway. No engine can run at 500 or 600 degrees. It's toast. So therefore, the plastic is totally usable at the oil temperatures of the heat of the oil and the engine temperatures that are being sent to it, because the engine does have to stay cool. Otherwise it blows up too. The metal fails and everything else. So your oil pan is going to survive no matter what, based on the regular operating conditions. Like I said, if it catches on fire, it's all over anyway. But the plastic oil pans, thermoplastic oil pans with nylon type fibers in them and other fibers that they put into these plastics, are designed for rigidity and also stability and structural integrity of the engine block. Because engine blocks these days are not just one big piece, they are about 3, 4, 5 pieces. So every piece goes together like Legos. And that plastic oil pan, that plastic valve cover, and that plastic intake are all part of the mix. Just imagine, they took all that aluminum weight out of the engine, and now you just have the working fundamental part of the engine, the block and the heads. That's it. They can't turn those to plastic yet. Who knows what they're going to do in the future, but the plastic oil pan is here to stay, folks. It has proven itself since 1990s. Now, Ford's got a problem with it, and I did a TSB. You'll see that up here. I'll put a card to it. But they've redesigned that too, because they figured out what the problem was. Because guess what? One weakness of things is when you start molding up plastic to aluminum, one is going to expand and contract different than the other one. That is where I'm thinking they're having a problem with this rigid seal material they're putting on. You know, while they use the gasket sealer essentially. What happens is the aluminum engine block that they have in the oil pan, thermoplastics, expand and contract at different rates. So as they expand and contract, there's movement and there's breakage of the seal. By putting the rubber silicone gasket around there, that gasket allows for movement. It allows for thermal contraction, because when the engine cools down and it's say 20 below zero, then it has to heat up to 200 degrees. That seal is going to not stand a chance based on the old gasket seals they've been doing, because it's just too large of a seal, folks. That's all there is to it. It's just too large. So therefore, they went to that silicone seal, just like the valve covers now. The valve covers have that inserted silicone seal all the way around them. That's there. So that is how they've adjusted it for the 2019 issues for the Ecoboost, the 2.7 and 3.0. That's what they've done, is updated that. Now you older folks, older edges, 2.7s, you're out of luck, because this oil pan isn't really a cross-reference thing. But plastic oil pans, hey, a little bit of engineering, I think they got it figured out. I often wondered why they didn't include a gasket with it, because a gasket is definitely your give and take. And in this case, they went with the silicone gasket, just like the valve cover. Valve cover has an inserted silicone gasket. Everything else is good. Well, this got a train coming. I'll be right back. Back at you with the train gone. Holy cow. Yeah, that's one thing I hate about that thing. But anyway, thermoplastic oil pans, here to stay. We're going to have a great time with them, and I see no issue with them. I like them. I think they're good. I think I'll go for anything that's engineered to be stronger and more durable. So I'm ready for that. So I hope you all are ready for it and understand more so now and can be more confident in what the oil pan is all about. The plastic is not a weakness. It is actually a strength. So next time you go to change your oil and you see that plastic oil pan, keep in mind, hey, it's fantastic. We're going to have a great time with it, and it has so many more advantages to it to make you go faster. And that's one other thing about weight savings. You can go faster, quicker. And this is MACTFORDEDGE, and I hope you like this video. Remember, like, subscribe, join MACTFORDEDGE on this channel. Also, Facebook. Join the Facebook group. We are a definite busy group there, and you will find no better FORDEDGE Facebook group on the internet. And that is a guarantee. People love that group. And also, guess what? Band of One's got some great music. That's right. Mercy Girl's got a couple one-liners. And my feet hit the floor today. I'm having a great day. And I want you to have a great day, too.
Thank you for watching MacT's videos. And remember to like and subscribe. This is a Mercy Girl production.